All right, welcome back. So we're continuing our unit on flight. You've done two previous experiments. One focused on the concept of balance and gravity and how basically all items look to find a balance or an equilibrium. So if it's off, gravity will force it back to in a balanced position and how we can correct those. You also looked at drag and the factors that affect flight in terms of the size of the plane, the materials of the plane, and how when things change, we need to make adjustments to make sure that our planes fly true, and the concept of drag. This experiment is going to focus on Bernoulli's Principle, which is one of the critical elements of flight. Previous to this video, I've posted a couple of informational short videos that kind of helped explain the concept of Bernoulli's Principle. And what I really want you to focus on is the use of Bernoulli's Principle and how it affects experiments we're working on today. Because essentially with Bernoulli's Principle, we're able to achieve lift, which is important for flight. So some terms we've looked at are balance, drag, and lift. So today we're going to look at the concept of lift. And you're going to do about 4 experiments that help reinforce that. Remember to not only observe what you're seeing, but explain why you think it's happening. So if you see something happening, you have to kind of say, well, why I think this is happening. And you can do a bit of research. You can ask me. I'm really looking to see you to be able to connect what you see to why you think it's happening. Okay? So the first experiment involves several pieces of paper. The first one is simply take a piece of paper. I'm going to do it by profile. You're going to hold it, and I want you to blow across the paper. Okay, so you're going to hold it as this. You're going to blow across and observe what happens. Okay, what does the paper end up doing? Okay, the second experiment that I want you to do is to take a piece of paper, fold it in as a tent. What I like to do is use another piece of paper to kind of keep it stable. And what you're going to do is you're going to blow through the tent. So in this V space, I want you to blow through the tent and observe what happens to the paper. So these two experiments are kind of in tandem. And once you see what's happening, you're then going to try to connect this to the concept of Bernoulli's Principle. Okay, so you're going to blow right through this little tented section here. Like I said, use a piece of paper to kind of help stabilize it. All right, so that's the first experiment. Again, everything's at the back table, just like in the previous experiments. For the next experiment, you're going to take these 2 cups and this ping pong ball, and you're going to try to get the ping pong ball in that cup without touching the ball. Again, we'll use the concept of Bernoulli's Principle to get this done. A couple of key things here. You're going to place the cups, it's very close, 5 centimeters, but you're going to place them perpendicular, lined up as such. I just do this as a side view, look at the distance. Okay? The thing for this experiment, a couple of things. What you need to do is you gotta get low. So what I'm going to do is I'm going to get low. A couple other things you need to do is I would use your fingers to hold the cups. So see how I'm holding the cup like this and place this down so that there's some stabilization here. Okay, you may want to do this as partners again or on your own. And what I want you to try to do is blow across the top of the cup. Not down into the cup, but across the lip of the cup. And see what happens. And see if you can get this ball to go into here. Okay, so you'll be blowing right across the top, right? And you might have to do some force. These experiments are a bit persnickety. It's a fancy word, which means kind of not difficult, but they take a little bit of focus and energy, and they may not work on the first shot. So don't get frustrated. All right, a couple of key things here. Hold on to your cups, all right? And as you blow across, see if you can, anything that happens. Again, observe what's happening, and then again, connect it back to the concept of Bernoulli's Principle, right? Can you really get a sense of what's happening and why things are occurring? All right, that's experiment number 2. The next experiment, you're going to get balloons at the back. You're going to blow them up, relatively the same size. Now, I know these are bouncy. Oh, and just let me reiterate, I know this ping pong ball is bouncy and can go all over the place. What I don't want to see it is rattling around the room. Okay, so it falls, pick it up. If you need to get it out of your system, you know, do a couple of bounces, get it out of your system, and then put it down. Okay? Please return the ping pong balls to the back table. If it rolls around, just be mature about doing your experiments, please. Again, with the balloons, you can blow them up. If need be, you can do the old bounce it. Okay? You can even get a little spike. There you go. 1 spike, and you're done. Okay? And it's out of your system, and you can move on. You're going to take these 2 balloons, place them about yay far apart. Okay? And then what you're going to do is hold them up above your head. And what you do is blow between the gap that is in between the balloons. So you're going to be blowing in between the gap and observe what's happening. Okay? So before you do that, try to think to yourself, all right, if I have 2 objects and I blow between them, what do I think is going to happen? What do you think intuitively might happen? So as you're blowing between, you're going to notice something that occurs. And of course, write that down. and record your answers. Any questions at all during the experiment, you can always come see me. Am I not doing it right, sir? And if you're doing the experiment and you're not sure if something's happening, come to me. Sir, can you watch that? And I'll let you know, just like with the candle experiment, if what is happening should be happening, or I might have to do a couple adjustments. The key is the gap in between, okay? And you want to blow right in between this experiment. An extension of the balloon experiment, okay, is to take two other objects. Usually what they say to use is soda cans or pop cans in Canada. So there's an excuse to drink pop or V8 if your parents want you to drink V8. And see if you can repeat the same thing. So you're going to take two items, place them relatively close, okay? And then you're going to blow in between the items and see if you cannot have the same thing happen to these two items that has happened to the balloon. Now there's a difference. These items are much heavier than the balloon, okay? So think of an airplane, right? We're trying to draw comparisons that we did a little experiment with balloons, which are much lighter, and think of then now replicating this with two heavier items. So when I blow in between to get the same result, my breath or the force that's in between these two items probably has to be greater or of a greater force. Okay, the energy that I'm giving has to be greater. Now, as I breathe, my air kind of gets dissipated throughout. It's not a focused breath. So the question is, how could I replicate this experiment, create the same energy or greater energy? Right? And this kind of connects to how rocket engines kind of work, or the principle of propellers and rocket engines and that kind of stuff. Right? Because what we are doing is we're creating force with our breath, but the breath isn't focused, and we kind of need a focus to create a really strong, powerful force of energy. So how could I focus my breath so that I have a greater energy? All right, so you're going to have to figure that one out. It may come to you right away. You may be like, sir, I have no idea what you're talking about. The only hint I will say is think of pea shooters. And if you don't know what a pea shooter is, ask your parents, or I can tell you what a pea shooter is. It's something we did as kids when we were being silly in class. Of course, it's strictly prohibited and would not be tolerated anywhere today. But the concept could work with this. Okay? So just to review, we have 4 experiments. Okay? We have the 2 paper experiments. One where you take a piece of paper, right? Blow across the piece of paper and see what happens. Your tenting experiment, a reminder with your tenting experiment. Use a little stabilizer, blow through the V. The magic ball, can I get this ball on this cup? Again, the distance is important, okay? Don't have to be so far apart, okay? Also, you want to blow across the ball. Oh, there's Gary Gold. He's making an appearance. Gary, you interested in science? All right, and again, you want to get low, hold your cups, okay, when you're doing this experiment, and you're blowing across. You got to kind of get parallel to the cups, okay, for the force to be there. There's the balloon experiment. All right, where you hold the 2 balloons, okay, blow in between and see what happens. And of course, can you replicate the experiment, which means repeat it with larger objects? So that's what science does. So they take something technically in a lab and they say, okay, it works with these items, but how do I work on a larger mass? Think of the newspaper airplane. Think of the cardstock airplane, right? They were heavier, larger, so you need a greater force. If I take the same 2 items, okay, can I replicate what's happening there? And how do I increase that force? Again, think of the pea shooter. All right, and of course, at the end, the best part is I can pop my balloons, and there you go. And of course, put the balloons in the garbage. Okay? Happy flying!